Hi, welcome to the notes for H2-5. Today we're going to look at modeling situations with quadratics. Our main concept that we'll be working on today is finding the stretch factor in our equations. Let's get started. Example 1. A rabbit is jumping over a fence that is 3 feet high. He has a vertical jump of 3 feet and can jump 8 feet horizontally. Find an equation to describe or model the path of the rabbit. First question it asks, where should we start? And then it also asks, where is our vertex, or HK? Above, it says that our rabbit has a vertical jump of 3 feet, and it can jump 8 feet horizontally. So if it's trying to jump over a fence that's 3 feet high, let's go ahead and put a fence in. So I'm going to put my fence right on the y-axis. You don't have to put it there, but for the sake of learning how to do these problems, I think this is a good way to start. So that's our fence. Our rabbit is going to need to jump over this fence. So if he can jump a total of 8 feet horizontally, and he can reach a height of 3 feet, we need to make sure that our rabbit is going to end up clearing the fence. Right? So at the very top of the fence, it's 3 feet. So his peak of his jump, which should be halfway through his jump, will be 3 feet. So if he can jump a total of 8 feet horizontally, that means we need to leave 4 feet on the left side and 4 feet on the right side. That's going to allow our rabbit to jump up, get over the fence, and come down and land on the other side. You'll see this looks like a parabola that happens to be opening downward. So think about how that's going to impact some of your parameters, your AH and your K. So with this one, looks like we're going to start from the point -4, 0. We're going to land at the point 4, 0, and the rabbit will be at the point 0, 3 when he's flying over the fence. That should help us now because if it's a parabola that's opening down, our HK value should be the point 0, 3. And since we're starting at -4, 0, or you can start at 4, 0, we're jumping across. So here's what we're looking to do. Y is equal to A times the quantity of X minus H quantity squared plus K. We already know that our vertex is the point 0, 3. And remember, H and K, right, will actually end up being just H and K over here. So let's put our point in for the H and K. So we've got Y is equal to A times the quantity of X minus 0 squared plus 3. Now what we need to do is we need to look at how can we figure out what this A value is going to be. We still have an input and an output to deal with, but we want to end up solving it for A. So what we can do is we can find another point to fill in for this, the X and the Y in our function. Let's choose another point that we know. Let's say like the point -4, 0. That's an X and that's a Y. So if we put our 0 in for Y, it should equal A times the quantity of -4 minus 0 squared plus 3. Now we're down to just that A, so we can try to solve this equation to figure out what it's going to be. So we have A times a -4 squared plus 3 should equal 0. -4 squared is 16, so 16 times A plus 3 equals 0. Subtract the 3, and then divide by 16, and we just found our stretch factor. Our stretch factor is going to equal -3/16. Well, now that we know that A is -3/16, H is 0, and K is 3, we can now rewrite our equation with those parameters in it. So we're looking at Y is equal to negative 3/16 times the quantity of x minus 0 squared plus 3. Or if you want to simplify it, I know when we have x minus 0, we can just take it one step further and say y equals negative 3/16 times x squared plus 3. Because remember, x minus 0 is just x. So either of those equations would be considered correct. Down below, it does ask, what is the domain and range of this situation? So you don't want to think about just the parabola in general. My parabola is not continuing to go on. It's, come to a dead stop on the x-axis on both sides. So our domain looks like it's going to span everything from negative 4 to positive 4. And our range is going to go from 0 up to 3. And that's it for that problem. Let's move on and look at another one. Example 2. When Miss Bibby kicked a soccer ball, it traveled a horizontal distance of 150 feet and reached a height of 100 feet at its highest point. Choose the point from where Miss Bibby kicked the ball. Sketch the path of the soccer ball and find an equation of the parabola that models it. All right, so it tells you to pick the point. If it's me, I like a lot of times to just go ahead and split that distance. If we're kicking at a horizontal distance of 150 feet, we know that highest point is going to be halfway through that. Okay, and then our highest point is going to be up at 100 feet. So like that first one, I'm going to put my highest point right on the y-axis. So I'm going to put 100 feet right up there. Now, if that's the highest point and that's at 0, that means that we need to go back 75 and have Miss Bibby kick the ball from back there. So this would be like the point negative 75, 0. And then it would extend out probably about 75 on the right side. So we have 75, 0. So she kicks the soccer ball. It's going to go up, hit here, and come back down on this side. Okay, so what is our vertex? Well, that should be the point 0, 100. So we kind of have an illustration set up, and we can now try to find the equation of the parabola that models this. So we've got y is equal to a times the quantity of x minus h squared plus k. We said that our vertex point, which is hk, was at the point 0, 100. I think we started at the point negative 75, 0, and we ended at the point 75, 0. Let's use this information now to solve to find our stretch factor for this problem. So first thing, let's put in our h and our k. So we have y is equal to a times the quantity of x minus, in this case it's 0 again, squared plus 100. And now let's just plug in one of our other points, right? Let's plug in the x for x and the y for y. 0 equals a times the quantity of negative 75 minus 0 squared plus 100. All right, so this is going to end up being a times a negative 75 squared plus 100. If we need to do negative 75 squared, let's grab out a calculator. Clear that out, and let's just do negative 75 times negative 75. And we get there 5,625. So we have 5,625. A plus 100 equals 0. Solving for A, we got to subtract that 100 from each side, and then we can divide by the 5,625. Okay, so let's see what our value of A is going to be. We've got negative 100 divided by 5,625 is equal to negative 4 over 225. So what's that mean? Well, our equation should look like this. Y is equal to negative 4 over 225 times the quantity of x minus 0 squared plus 100. Or simplified, that would be y is equal to negative 4 over 225 x squared plus 100. Okay, let's move on to another one. Example 3. At the skate park, the hot new attraction is the U-dip, a cement structure embedded into the ground. The cross-sectional view of the U-dip is a parabola that dips 15 feet below the ground. The width at ground level is its widest part at 40 feet across. Sketch the cross-sectional view of the U-dip and find an equation of the parabola that models it. All right, so it sounds like our U-dip will come down here and go up there. I probably could have filled that whole thing, but I didn't, so it's all right. And if we think about this here, right, so it says that it goes down to negative 15 feet below ground. Right, and then as we're going across, obviously this is not for scale, we need to set this up however we wish to do it. What I'm going to do is call this 0. So this is the point 0, 0. And I know that if I go 40 feet forward, I'd end up here. So that would be 40, 0. And if I'm trying to find my kind of like vertex point at the bottom, I know that's going to be halfway from 0 to 40. So we know that's going to be at 20. And then we're still down here at negative 15. Okay, so this one looks a little different than the last one because we're not straddling the y-axis. This would have been like our y-axis. This would have been like our x-axis. But let's see how this will work. Okay, so we're thinking about y is equal to a times the quantity of x minus h squared plus k. Our vertex on this one, we just found to be 20, negative 15. It looks like we were starting at the point 0, 0, and we were ending at the point 40, 0. All right, let's see if we can find our stretch factor. First thing, let's go ahead and put in h and k. So y is equal to a times the quantity of x, let's see, minus 20, and then we're going to square that, and then subtract 15. So step 1, we got the vertex in. Now we need to choose a point to put in for x and y. Well, if it's me, I have two options, right? 0, 0, and 40, 0. I'm going to go for this one. And the reason why, it's really hard to mess up and put x in for y and y in for x by mistake if they're the same number. So I would advise you, if you ever see that point, to use it. 0 is equal to a times the quantity of 0 minus 20 squared minus 15. This would be like saying a times a negative 20 squared, which we know is 400. So 400a minus 15 is equal to 0. Add your 15 to each side and finish solving for a. So I divide each side by 400, and a ends up equaling, and if you're not sure, you can just type it in on your calculator and figure it out. We prefer to have the fractions, not rounded decimals. So 15 divided by 400 equals 3/80ths. All right, so what does that do for us? Well, now that we know a, y is equal to 3/80ths times the quantity of x. Now, if we had our vertex at 20, negative 15, we need to do minus 20 squared minus 15. And that is the answer. Let's move on to the last one. Example 4. A golfer struck a ball that travels a distance of 300 feet at and at its highest point is 75 feet in the air. Choose a point from where the golf ball was struck. Sketch the path of the ball and find an equation of the parabola that models it. All right, so I guess we haven't talked much about this and we need to. All right, it keeps telling us to choose where we want the parabola to start. Let's think back to this last one real quick. I took it and I set it up so that it started at 0, 0, went down here to the vertex down at the bottom, and then went over. We could have set that up differently. We could have said, hey, my vertex is going to be at 0, -15. If I wanted to straddle the y-axis like we did in the first two, oops, I missed there, right? That's going to change these points, though. This point would have been -20, 0, and this point here would have been 20, 0. And we could have gone through and solved this the same way. When we do, it still ends up giving us the same stretch factor. Our only thing that changes really is this h value. Okay, h will change, but it's still the same stretch, and it's still got the same y coordinates for vertex. It just has been horizontally shifted. So with this one, we have a couple options as well. You could either say that we are teeing off from 0, 0 and hitting it, and then it's ending at wherever this point would be down here. Or you could throw your y-axis in the middle and do it that way, okay, like we did with the first two. I'm going to do it this way and say this is 0, 0. Okay, I know the golf ball's been hit 300 feet, so this would be 300, 0. And then halfway, we're at 150 feet, and it said that its highest point is 75 feet in the air, so we'll put 75 as the y-coordinate. Everybody understand where that came from? Remember, this is the halfway point across its path, so we want 150 as our halfway point, and we know it went up to 75 feet high. Let's go ahead now and try to solve it. So our equation that we're looking at, y is equal to a times the quantity of x minus h squared plus k. Our vertex on this one, we just said was 150, 75. That's our h and our k. Then we're going to take it here and we're going to plug that in. Y is equal to a times the quantity of x minus 150 squared plus 75. And we now need to choose a value to put in for x and y so we can solve for a. And again, your options that you'll have will be these endpoints that you've written down. And if it's me, again, I'm going to use 0, 0 because then I can't accidentally flip-flop the x's and the y's. So we're going to use that point 0, 0 here. 0 equals a times the quantity of x minus 150 squared plus 75. Oops, I'm sorry, we don't have the x in there anymore, right? What do we actually have in there now? A 0, right? Because this is x and this is y. So we have a times negative 150 squared plus 75. 150 squared is going to be 22,500. So we have 22,500 plus 75 is equal to 0. Let's subtract the 75 from each side, and then we're going to end up dividing by 22,500. In the end, we're going to end up with, I believe it's like, well, you know what, let's just do it so I don't say it and then it'd be wrong. I would have been right. Negative 1 over 300 is our stretch factor. Let's just put it into the equation now. Y is equal to negative 1 over 300 times the quantity of x minus h, so 1 minus 150, squared plus 75. And that is the equation. So this process isn't very difficult as long as you're just paying attention to what you're doing and that you draw your pictures accurately. One thing I want to point out to you, every picture we did here, you noticed that I wrote out ordered pairs on it. Okay, people who don't put down the ordered pairs make mistakes and get it wrong. So just please, please, please be careful to write down your ordered pairs. Don't just write down distances, actually write them as points to make sure that you're able to do it. That's all we got for this lesson. If you have questions, make sure you reach out to your teacher. Thanks for watching.